Okay, so a few housekeeping details before we start. We have the guides in the back of the room. Insect, in the other room. Insect, weeds, and fungicides, diseases. And some say, well, this says North Dakota on it. Can't use it in Minnesota. There's a tremendous amount of good information in these books that I think applies anywhere. So I would argue that there isn't good utility. I know a lot about this weed control guide, and a lot of the information that you find online in labels is in this book. So I would encourage you to take as many as you need, because we make a lot of them. We print about 12,000 of these every year and try to get rid of them. Okay, so I'm going to go to my slides here, Mark. I'm going to see if I can. So I'm guessing this arrow is the one that advances.
I believe so.
Okay. I decided I needed to put my acknowledgement slide first, because quite frankly, I can't be successful working in Southern Maine without the help of the co-op. So I want to make sure to acknowledge the people that help. So I want to start with our board members. So Brian, raise your hand. So Brian has been very helpful in reviewing proposals to make sure that we're doing relevant work. So Brian has a teammate, Mr. Lane Schwitters. So Lane, thanks for making time and attending our meeting this year. So I guess you worked around your ice fishing schedule this year so appreciate that. Thanks so much. And then, by the way, I've never had any of Lane's fish, so I don't know if he catches anything. And then the staff, tremendous support from the staff. And in my case, it starts with Mr. David Metler. So David's a real thin guy, and I worry about him pushing the bike sprayer all spring, but he's really a valuable asset to the team. And Emma's up here in the front row. I can't say anything. We get the same support from MNDAC, so thank you, Emma, as well. And then our cooperators. So nobody likes to admit that they work with the weeds guy, but we do have grower cooperators that support my mission, my work to try to do weed control work, and I'm very grateful for you for being my cooperator. So I decided I needed to do something different. I had a long 2025, just like everybody else. So at the end of the season, I decided that I got to get some ideas. And I asked Mark about putting a group of people together. We called it a focus group. About 15 people, a combination of growers, crop consultants, ag retailers, agriculturalists, just to talk about things and get ideas. And I said, we're not going to do this all afternoon. We're going to work 2 hours, and when we're done, we're going to summarize, and then we're going to, move on. And that's exactly what we did. And I will tell you, that was a very successful meeting. And some of the people from the Southern Maine meeting are in here today. And again, I thank you for your participation and your ideas. So a lot of what I'm going to talk about is some of the ideas that came from those brainstorming sessions. And I want to also acknowledge we did those in the other co-ops as well, and quite frankly, they're going to continue into February. Integrated weed management. As I reflect on my tenure, I wish I would have done more to make that weed control, the herbicide bubble, smaller. We have an awful heavy reliance on herbicides. And I'm going to talk a little bit about resistance towards the end of my talk, herbicide resistance. And I have some concerns that we have to get this into perspective, finding balance. So some of it's already been stated on cultural practices. One of the cultural practices are good uniform stands. So that's an example of how we can benefit our weed control. We have to start looking at those other areas because quite frankly, there's some headwinds with herbicides, new herbicide development that are concerning for me as a weed scientist. I want to start by talking about something. When I was a kid, I grew up with this guy named John Wooden, who was the basketball coach at UCLA, University of Southern California. And John was the coach there, I don't know, he might have been there for 25 years. I think he retired in the early 1970s. Oh, what happened? So one of the things that John says is, it's the little things. The little things make big things happen. And I think that's really the theme that I'm going to use in the rest of my talk today. And I'm going to go through a lot of things. So singly, these are little things. But I think if we can do these little things, it can equate to bigger things, which in my case is controlling weeds. So one of the things that happens is it's always a rite of spring is to get pictures about water hemp germination and emergence. So I grabbed this slide. This happens to be from 2020. And you can see the pictures, you can see the dates. Generally, water hemp germinates during the month of May, depending on what your location is. And David, one regret I have, another regret I have, David, is we didn't do a better job of tracking information not only about when we saw our first water hemp. Where did David go? Oh, there he is. David, when it first germinates, but when does half the population emerge per unit area? Or how many total water hemp did we have in a particular year per unit area? I think that would be real valuable information. So I think it's something that we start and we collect that information in the future. And I'm going to tell you why. I've got a short case study that I'm going to go through. So I'm going to use some data from a former grad student at the University of Minnesota, Mr. Eric Yo. So Eric didn't work with sugar beets. He didn't work in a sugar beet county, but he did track water hemp and some of the environmental conditions that's attributed to it. So I'm going to use the pointer here, and I want to focus on the data here on the bottom for a minute. So if you see the red line, the bottom line is the year 2022, the top line is 2023. So you can see that in many respects the years were the same, but at the end of the season we got a lot more rain in 2023. If you look at the data, the first emergence in 2024, or excuse me, in 2022 was May 24th. That's when we first observed water hemp. Interestingly, half of the population per unit area was up in 3 days. So what's going on with the weather in that situation? Now compare that to 2023. So our water hemp emerged a little earlier. We had 50% emergence well into June that year. And then interestingly, per unit area, we had twice as much water hemp in 2023 than we had in 2022. So I want to drill into that a little more. And we can do that by looking at rainfall. So I'm looking at April, May, June, July, and August. These are when water hemp generally emerges. And if I click on this, you can see that we still had more rainfall. We had more rainfall in 2022, but that's biased by all of this late season rain. What's interesting to me, in 2022, we got our flush of water hemp emergence from that May event. But it was very dry in June and July. And matter of fact, we didn't have any rainfall events of more than an inch during that time frame, back to what Kenny was talking about today. Now compare that to 2023. Mark, I'm having trouble here. Comparing to 2023, we had several spikes here where rain occurred. And you can see on the table here, rainfall events in late June and in July that I think contributed to germination and emergence. Now, it's not just rain that makes water hemp emerge. It's the temperature fluctuations that's associated with the rain event. And you can see that clearly in the data, both the air temperature data and the soils data. So this is old stuff. What about 2025? And this is from one of David's sites near Clara City. And this is during the growing season. So almost 35 inches of rain during the growing season. And look at all the spikes that are occurring, tracking the rainfall events. And if you put the events on the map where we had over an inch of rain, it's no wonder we didn't get water hemp control because of all the flushes of water hemp that we had during the growing season. We certainly had more than our normal year's worth of water hemp germination and emergence in 2025. So I want to push on. I want to talk about other topics, and you're going to see this slide a lot. This is a transition slide. So Cody, where did Cody go? Cody, a myth buster. The only place that has water hemp is Southern Maine. Not true. This is east of Fargo. It's near Prosper, North Dakota. And there's water hemp up here too. Matter of fact, every survey that we did last year, water hemp rated as the most important weed control challenge in sugar beets. So water hemp is certainly a challenge in all sugar beet growing regions. So I want to go back to some of the data from the survey, and this is from last year. And I really appreciate Lindsay's presentation because she talked about cover crops. And I'll take some responsibility, quite frankly, for less spring-seeded nurse crops. Because we've been planting, we've been using ethofumizate. Half of you that used a pre-emergence herbicide were using etho, and I'm guessing you were using more than 5 pints per acre, which wouldn't allow water hemp germination and emergence. Over on the right-hand side, on the left-hand side here, dual magnum. So at 12 ounces per acre, we can still grow cover crops, nurse crops in the spring. And I'm guessing that you selected dual magnum mostly because you wanted to also use spring-seeded nurse crops. And then over on the right-hand side here, dual magnum plus ethofumizate is a happy medium. Usually we're in the 2, maybe 3 pints per acre etho, and we're combining that with 12 ounces of dual. And I call that a happy medium. You get the benefit of dual magnum because it's easy to activate, and you combine that with maybe longer residual from the ethofumazate. Ronideptam, nobody used ronideptam, but I want to tell you that we continue to work with ronideptam in our research trials, and I'll be sharing a little bit of our data with you. Okay, I want to go through some products with you, just to make sure everybody's on the same page as to what's going to be available in 2025. So there's 5 different products listed here. Nectron from Atticus is crossed out. So Atticus has decided to withdraw from the ethofumazate market, and there won't be any Nectron available in our 2026 season. So on these products, last year I showed you data that indicated these products all perform the same. Now, I think that's really important. Don't make a buying decision based on one or the other. They all work the same, at least in my research. Now, one thing I need to point out is the Maxtron rate is a little different because it's a slightly different formulation. So you're going to have to factor that in when you make an application. So 6 pints of Nordtron isn't going to be the same as 6 pints of Maxtron. I want to dig a little deeper into ethofumazate. I want to talk a little bit about it because, quite frankly, I'm still frustrated by lack of consistency. Lack of consistency with ethofumazate. So the first thing, it's a group 15 herbicide. Group 15. That's the same family as the chloroacetamides. Dual magnum outlook. It's the same family as ronideptam. It's the same family as Zidua. So these are all in the same family, but they're part of different subgroups. So there's some slight differences probably in resistance management strategies from one subfamily to the next. But I want to remind you, they're all group 15 herbicides. So they work in the plants by inhibiting the development of meristems. So above ground, that's either the coleoptile of grasses or the hypocotyl of broadleaves. Below ground, it's the development of the root system. They also affect waxes. And I'm going to come back to waxes a little later. So I have 3 questions here, which summarizes feedback I get about ethofumazate products. So why isn't my ethofumazate performance consistent? I got rain on it, I got an inch of rain, why didn't we get the weed control that we expected? And my answer to that is I have some of the same challenges in my research and some of my plots. So there's 2 characteristics for ethofumazate that's important. One of them is it likes to bind to soil. So when you apply it pre-emergence, it's sticking to the soil surface, and we've got to break it loose and get it into the soil. That takes rain. I think it takes a steady 1-inch rain, and I'm not talking about an all-day drizzle. I'm talking about a good solid rain. Number 2, ethofumazate, out of the herbicides that we use, the soil residual products, is the least water soluble. The least. So that means it takes a lot of water to get it incorporated into the soil. Question number 2. Does rainfall overcome some of these characteristics? Yes, it does, but we've been doing other things. We've been increasing the rates. We've been incorporating, shallow incorporating ethofumazate. We've been pushing our water volume. And finally, we've been trying to apply it earlier and earlier, even the fall of the previous year, to see if we can get enough rain on it to get it activated. And the last question, and this one unfortunately I don't have a good answer for, does ethofumizate bind to residue? So last year's corn stalks or the wheat in rotations in areas to the north. And I don't know. I was visiting with Steve Rail about this earlier in the week, and we both agreed using application volumes, spray volumes, 15 to 20, maybe even more water, probably is a good idea to try to get uniform distribution of etho and reduce the amount of etho that might be bound to residue. Back to this idea of earlier application. So this is an experiment that David and I did in 2024 and 2025, David. So I'm gonna go through the treatments with you. So we had 3 fall treatments: dual magnum, ethofumizate, and Eptam. And then we had 3 spring treatments, the same 3 treatments, but notice the rates are different fall and spring. I thought we had really good consistency between dual magnum and Eptam. Now I'm missing one of the bars for Eptam. That's because I screwed up. That's my mistake. Now let's look at the etho columns. So here is another example of that inconsistency that we see sometimes. And I have no explanation for this. But it's something that's bothered me a lot about our program and our use of ethofumizate. So the other thing that, and this is data you've seen before, but I want to reinforce it again. The other thing, ethofumizate, the textbook says it's a full season herbicide. 10 weeks of residual. I disagree. Early on, we were using etho at 1 to 2, maybe 3 pints. And the idea that I would tell you in meetings is we don't need 8 weeks of weed control. All we need is weed control in the first 30 days until we get into the lay-by program. And I would argue our own data would say we're not getting that from these lower rates, not from etho alone. Maybe etho combined with dual magnum, but not etho alone. If we wanted to get to the level of weed control that we need to be in those higher rate echelons. So what does that mean for 2026? So the programs aren't going to change. Some of you are going to continue to use these higher rates. You likely won't be using cover crops. Some of you may elect to incorporate your etho. If you do, keep it shallow. In a dual magnum program, my favorite rate is 12 ounces. There are some soils where maybe that's too much. If we get to a later planting, I'd like to see you use a pint, even pre-emergence, especially if it's getting close to the 1st of May. But I think our most reliable program is that combination of dual magnum and ethofumizate. So I want to get back to the data, and this is some information that was developed by a gentleman named Carlisle Holan many years ago. And it was the sugar beet growth stage that corresponded to different growing degree days. And using Carlisle's information and other information about water hemp, the bottom line is a lot of our water hemp is germinating and emerging after sugar beet are at the 2 to 4 leaf stage. So our our chloroacetamide lay-by program continues to be a very important component of weed control in sugar beets. So the question that I have is, and this is a proposal to the board, maybe it's time we revisit these recommendations. Currently, we're using 12 ounces of Outlook followed by 12, 1 pint of dual magnum or asmetolachlor followed by 1 pint, and anywhere from 40 to 48 ounces of Warrant. I'm proposing we relook at those. And I am also proposing, even in 2026, we edge up slightly to improve our water hemp control. Now, in some cases, that may mean using one kind of product early and then following that up with another product later. So a 12 and 12 Outlook program wouldn't work in that scenario. You'd have to follow up 16 ounces of Outlook with something else, maybe Warrant. The other thing that I want to do is, and by the way, there's other formulations, other products, and I want to acknowledge those. But the other thing that I want to do is take a look at Zidua in sugar beets. Zidua. Now we know we can't use Zidua pre-emergence. The rotation restriction's 18 months. But Zidua might be a good in-season herbicide for us. And someone suggested we take a look at Treflan again. We know Treflan controls water hemp in soybeans. So this came from a different meeting. I'll back up a step here. I want to remind you that we have 12 ounces of etho to work with post-emergence, 12 ounces. And I urge you to use it. So it's back to the mode of action slide. Etho affects cell waxes. It helps to get more glyphosate into the plant. Especially early on, in 14 and 15, when I was doing a lot of this work, we consistently saw better water hemp control when we combined glyphosate with ethofumazate. We were getting a 15% bump. So take advantage of etho post-emergence. Use the 12 ounces that you have. Truvera. So Truvera is sugar beet that combines 3 different herbicides: glyphosate, glufosinate, and dicamba. David and I have been working on this for 5 years over in the Bloomkist area. Matter of fact, some of you have driven by, hit the brakes, and you'll say, what the heck are you testing out there? What are you doing to get that water hemp control? And it's these programs. So we're making progress on this. Mr. Lynn Dusick is somewhere in the audience. If there's any regulatory questions, we'll direct those to Lynn. I want to talk about the technical part for a minute. And I just want to hit the high points on this. So this is going to be very helpful technology for us. So I'm focusing on water hemp control here. We're going to use etho pre-emergence like we always did. And we're going to decide about either putting dicamba in with the etho or saving the dicamba for early post. It'll maybe be dependent on the season that we have. I personally really like dicamba early post in with the first chloroacetamide application because it'll clean up all of the emerged water hemp that we have. We're going to continue to use the chloroacetamide program. I don't know that we need 2 applications, but we're certainly going to use 1. We don't have to exactly be at the 2-leaf stage, but I'd like to get that on early post-emergence, no later than the 4-leaf stage. And then we're going to follow that up post-emergence with Roundup combined with glufosinate. Glufosinate. Now, I'm not saying Liberty Ultra. Liberty Ultra is not approved for sugar beets, and I don't see it being approved in the near future. So what we are going to be using is some of the other glufosinate products. We're going to work with different adjuvants to make those perform. And that'll be the work that we continue with in 2026. Few pictures from the field. This is from up by Sabin, Minnesota. Our untreated check, there's both water hemp and common lamb's quarters in there. Here's our standard. I call it the platinum program. Etho plus dual magnum, followed by outlook. Nope, I guess we have, followed by outlook, followed by warrant. And you can see we've got weeds in those plots. And then the programs where we integrate dicam and glufosinate, those are clean plots. These are going to be good programs when we can use them. Next topic. So integrated weed control for me is not just about sugar beets, but it's about the other crops in the crop sequence. And I urge you to map out the best programs that you can for controlling water hemp in your rotation. Map them out, put them on the chart like I did, and try to find places where you can mix it up, have variety. In my opinion, there's too many 15s on this map. So 15s alone can't be our way towards water hemp control. But use the winter to try to figure out strategies for how you're going to control water hemp across crops. Now, this is an idea from the focus group and a meeting that I had after. And I need to give Dorian Gashel credit for this. So Dorian's in the back somewhere. So years ago, we used to have something called herbicide take action and herbicide classification. And I've got an example of this chart in front here. And Dave Nicolai and I are going to put copies of this out on the table. If you're interested, you can pick these up on the way. What we want you to do is relearn herbicide mixtures. We want you to learn about what's in these premixes, to figure out what families of herbicides are in these mixes, and then to figure out if they are effective herbicides for controlling weeds. So I've got a list here, a process list of how you might approach weed control. So starting with identifying what the most important weed is in the field. Of course, that's water hemp. Making sure you're aware of any resistance concerns. And like I said, I'm going to talk about that in a couple of minutes. Looking at different premixes, figuring out what the components of premixes are, making sure the components are giving you effective weed control. And in my book, that means 95% control. And then using the weed control guide and making sure the crop rotation restrictions match what the programs that you're interested in doing. And I'm going to give you an example of that. I picked on two different products. So the first one I want to talk about is Acuron. So what I see with Acuron, and by the way, I don't know much about Acuron, but what I do see is a product that has application flexibility, application PPI pre and post. You decide on the rate based on the organic matters of your soil. Seems pretty flexible. It controls a lot of weeds. The one thing you have to worry about is rotation flexibility to sugar beets. So if you're on a soybean, corn, sugar beet rotation, it would have to be in the first year of corn. It couldn't be in the second. So what does it do? Well, there's 4 different products in Acuron. So there's a product called bicyclopyron, mesotrione, atrazine, S-metolachlor, and at least in principle, these are all effective water hemp control products. They're all effective products. Now, for that field that I showed you by Prosper, my use rate would be 3 quarts per acre. We have about a 4% organic matter in that field. The next part of this is making sure that that rate is an effective rate for controlling water hemp. And that's what I did here with the table. I went out and I did the math to figure out for that 3-quart rate, how much of each component would be in the mixture. And then I went to the label and said, what does the label say is the rate to control water hemp? And you can see the one here where we're not aligned is the atrazine part. The label would say you need more than 3/4 of a pound to control atrazine. Now, the other thing about Acuron is there's atrazine in it. I know a lot of you would prefer to save the atrazine for post-emergence application to be combined with Laudis. And of course, there's an Acuron Flexi product where they don't have any atrazine in it. So that's one example. I want to just do one more, just to make my point about premixes. So this one's called Triple Flex. So in some respects, it's just like Acuron. Application flexibility, it controls a lot of weeds. There's a rotation restriction here as well. But there's only one effective water hemp herbicide in this premix, and that's acetochlor. Acetochlor isn't going to be a season-long product for controlling water hemp at all. So my point here is read these labels, make sure that you know what these combinations are, and make sure that they're effective for controlling your target weed. Next topic. So I want to talk about nozzles for a little bit. So I have a background in this area. When I was a grad student with Dr. Dexter, my research was about high-pressure sprayers for Cercospora control. And to some degree, I've remained a nozzle head, interested in spray nozzles and what's going on there. Now, there used to be a lot of universities that focused on spray quality. North Dakota State being one of them. We had a guy named Vern Hoffman. Well, we lost Vern. He retired. We didn't backfill his position. And quite frankly, I don't know of any U.S. programs where there is spray quality research. But there's 2 guys up in Canada, Tom and Jason. And they have a website here. I would encourage you to use their website if you're interested in spray quality. They're very helpful people. I email them a lot, and I think their website and their newsletters are very, very useful. So the first question is herbicide, fungicide. Dave's already done the fungicide part. I'm interested in herbicides. Now, a very common question I get in the spring is, Peters, what spray volume should I be using? I would prefer you ask me, what droplet size should I be using? And that would correspond to the products that you're using and what's important to you. You know, for some of you, it's good coverage. Some you're worried about reducing spray drift. Does the brand matter? I'll get into that. Ultimately, we have to worry about what the label says. But change your view on this. Instead of spray volume, start with what size droplet should I be using for the spray project that I'm going to be undertaking. Spray nozzles, different brands. Years ago, they standardized what it means to be a medium-sized droplet. So I don't care if you're using a spraying systems nozzle, a Wilger nozzle, a Hypro nozzle, everybody is using the same classification system today. And they're color-coded, so it makes it pretty easy, pretty flexible to use. So then go to the table. You know, in my case, I was interested in a medium-sized droplet. I want to spray 20 gallons of water, and I'm going to drive 10 miles an hour. And use the table to figure out what kind of droplet without compromising that decision to use a medium-sized droplet. So occasionally people ask me to review their work. And this is an example of a paper that I recently got. They were doing work with Liberty Ultra, which is a glufosinate product, and they were combining it with Enlist 1, which is 2,4-D choline. And you can see the results here. I don't really have much to say about the benefit of the combination, but what caught my attention is the difference between nozzles. One nozzle was giving us a lot better results than the second nozzle. That caught my attention. So they had more information. They had information about different droplet sizes. So with the nozzle that worked pretty good, brand A, there generally was similar control, pigweed control in this case, across the different size droplets. With brand B, there was quite a difference. The bigger droplets didn't give as good a control. Here's my opinion. I think spray nozzles are all the same. To me, this is generic equipment that works equally as well, provided that you set up your spray equipment correctly. In this case, they weren't getting the right pattern at all. We learned years ago that turbo T-jet injection nozzles work better at higher pressure. The reason being is because you get a full pattern. The second thing that you could see in their data is there were streaks. Their pattern wasn't adequate for getting good weed control, and that explained the differences between brands. So back to setting up your equipment in the spring, it's one thing to calibrate, but it's another thing to make sure that you have a good spray pattern for good coverage. Today we want 100% overlap, which means the outer side of nozzle A on my right should touch the middle of nozzle B, 100% overlap. And that's different than it was when I went to college, when they talked about a 30% overlap. So in my opinion, preparing to spray is more than just doing the calibration. It's making sure that the products that you're using and the spray equipment that you're using all equate to the appropriate coverage and overlaps that you need. The other thing, and this was in the same paper, they talked about travel speed. So they had big weeds and smaller weeds in this particular paper. And it's interesting, with the bigger weeds, they were getting similar control at 6, 8, and 10 miles an hour, and they had less control at 12 miles an hour. So 6, 8, and 10 all shared the letter A. They were all the same. In my opinion, those were bigger droplets that were bouncing into the canopy and getting into the canopy itself, and that equated to the uniform control. I think on the other side here, on smaller plants, these big droplets that I think you're getting with these faster tractor speeds probably bounced right off small weeds, and that equated to less control. Next topic. I want to talk about something called harvest weed control, harvest weed seed control. So I've got my friend here, Dave Nicolai, that's going to answer the tough questions. This is machinery that you bolt onto your combine. It's from a Canadian company called Redicop. And the idea here is that you're grinding up your weed seed. You're grinding it up so it's no longer viable. And it's interesting, one of the characteristics of pigweeds is they stay on the plant all through the year. So the idea is you can run your combine through, you can take these plants with the seed still intact on them and then run it through the grinder that's on the back of the machine. So that equipment looks like something like this. Up in Fargo, I've got a contact at RDO called Tony Kramer. Tony does not work with any stores. I find that the stores don't know a lot about some of this equipment. Tony is the same guy that I use for information about the See and Spray systems. But anyway, this equipment bolts onto the John Deere combine. I think they have similar equipment for Case IH. And you can see the debris goes through the combine, it's ground up. And you can see from some pictures, this is at Carrington, one of the research facilities in North Dakota. It's like it's gone through a feed mill. So in this example, they're just grinding up barley just for show. And you can see how thorough a job that the equipment is doing. Here's another picture from Carrington. On the right, it's without the harvest seed destructor, and you can see how green it is already. On the left is with the equipment operational. Now, there's one significant drawback with this equipment, and that's that it takes horsepower and it takes diesel fuel. So their tractor speeds are similar, but you can see from these data, and there's a lot of data up here across crops, that we're using more fuel and we're certainly reducing the capacity component of the combine. So what have we learned? This has been some work that's been done at a number of universities, including University of Minnesota work with Dr. Devlin Serengi, and David's been involved in that work. So what we found is these machines can reduce the amount of seed that's returned to the soil. If we don't have any new seed, that's going to reduce the amount of water hemp germination and emergence. So how effective is this equipment? It's dependent on that seed staying on the plant. And pigweed's a good candidate for that. So these are machines that you're going to realize the benefit over time. They're pricey, they cost money, and then I mentioned the drawbacks that you have. It'll slow down your harvest efficiency. But back to that first drawing that I had, this is an example of how mechanical weed control can complement some of the other techniques that we have for weed control. Okay, I got to talk about Stinger for a couple of minutes. So I've been mainly talking about water hemp. Stinger is mainly used for common ragweed control. So one of the biggest drawbacks that I get is that Stinger is curling up my leaves and it's robbing yield. So we finally, and I think there's something to be said about the injury. Certainly under higher humidity conditions, we see more of this leaf curling, and certainly when sugar beets are a little further along, 4 leaves, 6 leaves, maybe even 8 leaves. So I think there's some truth to what I have in the pictures here. So what we did as an experiment, or several experiments, and both Emma and Dave were part of these experiments. We had multiple objectives. What I'm going to talk about today is just looking at Stinger at 3 different rates. And then I'm going to very briefly talk about Stinger integrated with insecticides and fungicides. So we used Stinger combined with Roundup at 1.8 fluid ounces twice, which is my standard recommendation today. And we compared that to 2.4 twice and 3.2 twice. And what you're looking at here is malformation injury, that leaf curling injury, 7 days, 9 to 14 days. So you can see that we had some injury. Absolutely measured that injury in our evaluations. And this is what it looked like. These are some pictures that Dave took from our experiment at Prindsburg. And you can see that leaf curling. Maybe the higher rate, image 3, has more injury than 1 or 2. And then looking at yields. And these were very, very good good yield experiments. Our ability to detect differences was less than 2 tons per acre. And again, the bars all share the same letter A, which means that Roundup had the same root yield as Stinger at 1.8 twice, Stinger at 2.4 twice, or Stinger at 3.2 twice. Now, there's a little drop off in sucrose, but there's no statistical differences there either. Now, there's other components of this, and we'll have that into the report. I don't have time to go through that data. But one thing that I do want to show that I think is interesting, and it's something that we would like to continue with in the future. So we've seen that Quadris interacts with some of our soil, some of our herbicides. And we see more injury. And we can see that in the malformation data here as well. And you can read the different combinations. So what the base herbicide was is Roundup plus Warrant plus ethofumazate. And then we combine different things with it. So what I want you to see here is the difference between Ascalia, one product for rhizoctonia control, versus as another product. And Syngenta has a new product called Elatus. We would like to test Elatus to see how it responds, hopefully in 2026. Okay, I'm very interested in glufosinate. And part of that is because that's going to be part of the Truvera system. So one of the things that I'm interested in is understanding environmental conditions to maximize efficacy. So what people say about glufosinate is you want to have warm, sunny days and humidity. Sun, warm weather, and humidity. But then they'll come back and say, well, what you want is humidity, and then warm, sunny days. So we tracked what the humidity was at one of our research sites. And what this data says is we had more humidity the second part of June, in this case, than what we had in the first part. And we saw this in our results as well. So the question that I have is, are you going to not spray because the humidity isn't high enough? And I've been asking this question for a while now, and some say, nope, we're not going to spray. We're going to wait until we have humidity. I don't agree with that. I think because of how fast water hemp grows, you've got to spray it when most conditions are correct for application. So in my opinion, what that means is spray quality again. It's using adjuvants in this case. And that's something you're going to have to get used to with the glufosinate system. These different glufosinate products are going to have different adjuvant systems, and we're going to have to maximize efficacy by adding different products with different glufosinate products. So Winfield's total is different than Alba's surmise, as an example. So it's going to be part of the learning curve that we're going to have when we start to use the Trevera system. One tool that I think is going to be very helpful is tracking delta T, which is both the interaction of humidity and air temperature. So the ideal range for delta T, and again, it factors in humidity, is between 4 and 14. The beauty is that we've got a weather network now in both North Dakota and Minnesota where we're tracking delta T real time. So you can either go to the website or you can go to the online tool that they have at EndOn and very quickly check on application conditions at application. Back to mechanical. So you all know that I've been a little bit cold on the weed zapper over the years. I have come to appreciate what the weed zapper does do. It is part of that integrated weed management solution again. And they're making some improvements on these machines that I think are really good. So last summer I rode along with Mr. Kruger and got to see how this new scratch pad works. And it roughs up the water hemp before it zaps it. And I think those kinds of improvements, and then using this equipment, like I said, in that integrated program, is going to help us with water hemp control. The other thing that we get, and this is real, we're seeing less seed. So it's back to this theme of if we get rid of the seed, we're going to eventually get rid of the water hemp. We're denaturing the seed when we're running through the field with the zapper. Now these are plants at flowering time. It's not going in before harvest and saying, I want to get rid of that seed to make it sterile. It's using this machinery in July when it's making seed. The last thing, and I just got a couple of slides left that I want to talk about, is herbicide resistance. So I don't like talking about resistance. And to be honest with you, I previously didn't understand why a lot of my colleagues like to talk about herbicide resistance. To me, it was about generating a lot of information that was all bad news. But I think I've come to understand why they were doing this work. I think it's absolutely critical that you know in your counties, in your fields, on your farm, what weeds are potentially herbicide susceptible or resistant. That's part of the weed management strategy. And unfortunately, this has gotten a lot more complicated. It's more than just Roundup resistant water hemp. Now it's 2, 3 different 4-way combinations of herbicides that aren't controlling water hemp anymore. You need to know this before you go to the field. And for this reason, I think especially those of you that are in positions of influence with the different commodity groups, demand that our universities are continuing to do surveys, continuing to develop genetic tests to help make sure we understand weed resistance. Now, I'm going to go through a scenario with you with the chloroacetamides. We talked about this a few minutes ago, and I'm going to talk about them again. So you're all familiar with these. I've got a lot of them listed. I'm sure I missed a few. But they're an extremely important component of our weed management strategy. So my colleague at the University of Illinois did some work a few years ago. So this is from 2013. So we had two different rates of harness herbicide. The top rate is the label rate, the 2X rate, and then there's dual magnum. And you can look at the visual control, only 7% control, and that is similar in terms of weed numbers to what was in the untreated checks. So it looked like dual magnum wasn't controlling water hemp at this particular site. So I asked Aaron, what did you do with this information? And he said, absolutely nothing. This was in seed production. They had year after year used high rates of dual, and we just thought it was a product from using the same herbicide year after year. We did absolutely nothing. Unfortunately, they've had a couple of more of these situations that have come up. So one answer, if you look at the data, you might say, well, it looks like we've got to quit using dual and maybe switch to a different chlorocetamide. And I'm going to tell you why that is not the right answer using the next couple of slides. So what our bench scientists do are experiments where they look at 8, maybe 10 different rates of a herbicide, starting at a very low rate all the way up to a very high rate. And they call this a response curve. So it might look something like this. So rate is on the x-axis, and then what they're doing is they're measuring something. The one that they like to use is a reduction in plant biomass, and they're getting a curve like this. So in the greenhouse, it might look like this, where you can see the pot here, different dual magnum rates. There's our label rate, and then these different biotypes of seeds. So what they're getting from this is a ratio, a resistance to sensitive ratio, and unfortunately what they're finding is that all of the chloroacetamides have some level of water hemp resistance in this population, which is terribly disturbing to me. Again, go back to that earlier chart. We're using the 15s over and over again. So I want to just go through what the implications of this are. If I'm out looking at a field where you call me and say, Peters, I don't think I'm getting the weed control that I expected. If you're using a post herbicide, I can ask you about the rate, I can ask you about the time of the stage of application, and then I can see the control that you got in the application conditions that you had. And it's pretty easy to summarize if something's going on. It's a lot more difficult with soil residual herbicides because there's a lot of factors that impact the performance of soil residual herbicides. Did they get activated? How much rain? When did it rain? Did they get too much rain? All of those things can influence. So I want to try to boil this down with a cartoon. And if you apply a label rate, and I'm going to just use Outlook example, as soon as you're applying that, it's starting to degrade in soil by microbes. And by the way, I think herbicide degradation to some degree is a good thing. So that's just naturally what's occurring in soil. And the length of control we get, 2, 3, 4 weeks, maybe 6 weeks with etho, is all dependent on the herbicide itself. So at some point, as that herbicide starts to deteriorate in soil, you get to a point where the water hemp are starting to tolerate it, to germinate and emerge. I call that being below a threshold. And that's just something that's naturally happening. And that's one of the reasons why we use the layered approach. When we get below the threshold, we're putting on another dose. What we're seeing with resistance is that happens a lot sooner. So instead of maybe 3 weeks before you cross that threshold, it might only be 10 days. These guys at Illinois did another experiment where from a molecular standpoint, what they found is in this population, it's degrading the dual magnum just like corn degrades dual magnum. So the weed is using the same process to degrade the herbicide. It takes corn about 2 hours, and it takes these weeds in these susceptible populations the same amount of time to degrade the product. So this is something that's really, I think, concerning to me. Now, in Minnesota, Dr. Serengi has worked on this. He's been working with different populations. His student, Nevjot Singh, has been doing this work. So they've been looking at, I'm trying to find the pointer here. They've been working on group 5s, the triazines. They've been working on the auxin herbicides, maybe dicamba, and then the PPO inhibitor herbicides, like Flexstar or Ultra Blazer. And you can see the maps that we're getting. The atrazine map is very similar to what Joe Eichley is observing in North Dakota. So we've had atrazine resistance a long time, but pigweed is making that resistance more common. That's concerning. But it gets back to my point. We've got to continue to do these surveys to make sure that we're continuing to update these maps. So somebody said, well, how are you going to do your recommendations? And what I'm going to tell you is I'm not going to change a thing. I think it's important for you as growers or the consultants in the group to continue to plan your programs and scout. And when you see things that don't look right, then we'll make the appropriate adjustments. But to say we're not going to use certain products because of what's happening in Illinois just doesn't make any sense to me at all. The other thing, and I've mentioned this a couple of times now, take advantage of the commodity groups when they want to offer to test your weeds for you. Tank mixing, effective herbicides like we talked about with Acuron is important. Use these other strategies that are going to complement your control. So I don't want to end on a sour note, but on the other hand, I got to inform you that some of this is starting to get pretty serious. Water hemp's a tough weed, and for a number of reasons, it's been able to overcome a lot of the products that we've been using. That's my last slide, Mark. My contact information, I know a lot of you have it. If you don't, it's up here. Call me if you need me. And with that, I'll take any questions. Lynn, be on the lookout. Dave, anything that you want me to clarify for you. Questions? Sir, Dorian.
2 questions, actually.
Yes.
On one of the slides, you had the percentage of control days after application on different rates of ether.
Yes.
And just kind of curiosity, at about day 55 on all the rates, there seems to be a little uptick.
Yeah.
Why was that? Then the second question is, group 15 is susceptible to organic matter. I've been suspicious that acetylchlor inconsistencies because of that, because of ethyl being that much less water soluble, is it organic matter contact that's causing the problem?
Okay, so Dorian asked 2 questions. The first was in my ethyl graph, why we saw the uptick. You know, I think it was going out and taking notes, and I was just in a better mood or a worse mood, and my scores got a little harsher or a little easier. So that's the only thing. I think the trend line was going down, but there was a little bump, and I can't explain why that would be. The other thing about organic matter, this is almost like, it's almost like saying that I see a ghost. You know, other people have whispered that, you know, there's something going on here that I'm not sure about. Am I seeing things or is it real? And I think you're absolutely onto something here, Dorian. Is this organic? You know, what is the contribution of organic matter? I don't know. I can't help you. I can't answer that part of it. But I think your suspicions are probably right. Other questions? Other questions? Anything about Truvera for Lynn? I hope a year from now I can talk about Truvera. We'll see what happens there. Question?
With Truvera, when do you think we'll be able to use that?
That's why Lynn's here. I know the technical answers. I don't know the regulatory answers. Lynn, you want to get up and address that?
Yeah, you bet. Thank you for the question. We continue to work through regulatory things as it relates. We continue to run through the regulatory process with Truvera. We've been working to get this to the market as quickly as we possibly can. We've been working on this since 2015. And we are on track. There's been a few slight hiccups, as you know, with dicamba regulation. But happy to report that we have achieved with the Truvera trait both FDA approval and approval from the USDA on the trait for use in the United States. So that's a big thing. We're really excited to bring potentially 2 additional modes of action to the market on the herbicide things, both potentially dicamba and of course the glufosinate side. So as we get these approvals, which we have here in the United States, another portion of this is related to the byproducts of sugar beet as it relates to export markets to other countries. So we're waiting for some of those approvals yet. We have about 12 countries left waiting for those approvals. We hope that most of those approvals will come within this calendar year, 2026. With that said, it could move into 27 and 28 in select countries for those approvals when it relates to dicamba. However, we have opportunities, right? We're going to continue to start looking at what we call a targeted stewarded launch in select markets as we start ramping up seed production for potential OVT entries and a potential target, again, like I said, targeted stewarded launches in 2027. So we're going to be in contact with the co-ops very closely, working together with them to get this. We realize that, you know, these weeds are very important to control for all of us here, and we're going to get this to us as soon as we possibly can here, Tom. So,
Lynn, I just want to reinforce the glufosinate piece. So make sure you keep me within the guardrails. The original regulatory work with glufosinate was done many years ago. And that work was done with what we would call glufosinate 280. So Liberty Ultra will require additional regulatory work. So we don't have access to that in the short term. What we do have access to are the other glufosinate products that are those traditional 280 products. Now the challenge with those is going to be the adjuvant loads in them tend to be product specific. So we're going to have to maximize that one glufosinate product at a time. So what we do for surmise might be different than total, for example. So what we do beyond or how quickly we can pivot to the other products, really that's up to KWS and maybe the manufacturers. Did I get that right?
yeah, you did, Tom. But one thing to emphasize here as we continue to work with the CP side of the business as well is we recognize that we need to have product for the market as well. So we continue to work with the CP side to ensure that there will be adequate volumes of glufosinate for the markets as we launch into these products. So there's going to be a there's going to be ample supply of these GA products.
Absolutely.
As we move into the LGA, as Tom mentioned with Liberty Ultra, that new formulation of glufosinate, again, that's going to take a little bit of time. But in the meantime, rest assured that that product will be available.
And I just want to reinforce, we've dropped these off at lunchtime. If the chart and the information on these charts is useful for you, important to you, pick them up. I don't know, Dave, we got maybe 75 of them out there.
Probably close to 700. They're on the table out here.
Thank you. So pick them up if you're going to find them useful. Anything else before I turn the floor back over to Mark? Or he yanks me off the stage. Thank you, everybody, for your attention. Have a good season. Call me if you need me.